Welcome to our Signal Media Executive Interview Series. I'm Kimberly Underwood, Director of Digital News Media at AFCEA International Signal Magazine. Welcome to our episode today entitled Innovating at the Edge, Unlocking Resilient, Mobile, Multi-Orbit Communications, which is sponsored by Tampa Microwave, which is a Thales company. Today, I'm speaking with Aaron Brosnan, President of Tampa Microwave, who will talk about next-generation satellite communication and the company's strategic investments in mobile, expeditionary, and modular command post communication solutions. Nice to meet you, Aaron. Thanks for joining me today.
Hi, Kim. Good to meet you too, and glad to join.
Great. I'm so happy to kind of delve into Tampa Microwave and kind of how you all are really enabling, true multi-band, multi-orbit connectivity across commercial and military satellite networks. Can you talk about that a little bit? And then why does that matter to the warfighter?
Yeah, so maybe I can take a step back. Tampa Microwave has been supporting military satellite communications for, going back to the mid to late 80s, 1980s. So, different technology then and a different ecosystem, different market. Back then, everything was geosynchronous orbit. So imagine a satellite that's fixed in the sky and you pointed an antenna at it and then you could walk away. You didn't have to track anything. That was a monolithic architecture. But it was perfectly suitable for, the way we fought missions or conducted missions or fought battles back in the day. Fast forward to today, where there's a higher demand on access to data. It's always more data is more important. It's also a higher requirement on resilience, so that you always have access to that data. And so there's also the advent of non-geosynchronous orbit satellites, really driven by the commercial industry. And for the same reasons, it was about how can I get more coverage around the globe? How can I get more data to the users? And how can I make sure that that's a reliable mechanism for getting access to that data? You can imagine that the military has those same requirements. They need to be able to deploy around the globe. They need to be able to access resilient, high throughput data anywhere that they deploy. And so the whole industry has changed. And so has Tampa Microwave. So for us to be able to address that new need, now we have a whole new range of products, both partly through an acquisition, but also through internal investments, organic internal investments, to address what we call, I think it's a misnomer, but it's called multi-orbit satellite communications. And I'll come on to why I think that's a bit of a misnomer. But anyway, that's where we're at, and we're excited about the future of this market and this space.
Right, sure. And especially in this day and age, companies really need to be tuned into their end user. Can you talk about that a bit and kind of what customer requirements are driving your investments?
Sure. Okay. So this is maybe the good opportunity to talk about, multi-orbit versus what I call multi-network. And if you think about your cell phone today, you turn it on, you might roam, around locations geographically. You might actually take it home or take it to the office, and it's just automatically connecting to whatever network's available to it, right? Whether it's Wi-Fi, Bluetooth, or cellular. The idea with the future satellite communications terminal is that you can get on any network. What defines a network? It's a whole bunch of things, including the orbit that the satellite operates in. So hence multi-orbit. So, and again, I mentioned in the old days, geosynchronous orbits. Now a lot of the importance in military communications is non-geosynchronous. For a couple of reasons. One is because, non-geosynchronous effectively means, you're running on an orbit around the Earth that's much closer to the Earth. So you can imagine that's important because it gives you much, much lower latency in terms of the round trip over the satellite and then back down to the Earth. So that's important. You also have, more state-of-the-art satellite constellations and payloads that are running more complex waveforms that are much more broadband, so you can get much higher throughput data. So that's important as well too. And then just the fact that you have multiple satellites in multiple orbits gives you a lot of what we call path diversity. So the ability to be able to connect to any satellite in any orbit in any region dynamically. And you can imagine if you get jammed on one satellite, you can quickly move to a different satellite and maintain your communications. So that's path diversity, and that's important. So back to orbits and networks. So what else defines a network? We mentioned orbits. We can also talk about the band that it operates in, right? So you can imagine, a very important constellation these days for the military is Starshield, SpaceX. That operates at Ku band. If you look at Amazon Kuiper, that operates at Ka band. And if you look at OneWeb, that's operating at Ku. If you look at a lot of the legacy WGS geo satellites, those are X band. So there are different spectrums or frequencies within the RF spectrum. So again, you need a terminal that can maneuver both across orbits, but also across bands, spectrum. And then I would say the last thing is, the modulation types, right? So every network has kind of a unique way that it scrambles the traffic to get it over the RF. Modulates it and demodulates it. So you need to be able to, adjust your modulation schemes depending on the network that you're riding on. And that gets pretty complicated because, like I said, a lot of those modulation schemes are proprietary to the network. So then you have to think about, okay, how can I somehow virtualize those waveforms so that I can access them dynamically on the fly? And then so there's a whole move towards waveform virtualization in terms of the modem architectures and the future terminal architectures. So multi-network is really what we're talking about. Multi-orbit is just one piece of that.
Right, sure. And as far as end users, whether it's soldiers in tactical units or those at, command posts, what can they expect from Tampa Microwave's next generation of SATCOM terminals?
Absolutely. Good question, Kim. First of all, the new peer threat is demanding a much more agile fighting force. So, you can imagine in the past at a division level, fighting force, you could take days to weeks to set up a command post and days or weeks to, tear it down to move it. That's just unacceptable in a modern day peer threat environment. We need to be a lot more agile, which means smaller, lighter, more maneuverable. So I think one of the things about Tampa Microwave is that we started with special forces. So everything for us has always been about expeditionary warfare. So we've always been, as small and light as we could possibly make it. Now what we see is, okay, let's now migrate to the new multi-network constellations, but do that in a way that we maintain that level of, really small, light, maneuverable, small package solutions. So that's an important aspect of the future requirements that are coming. I already talked about the fact that the idea of the multi-network gives the soldier on the ground a lot more resilience in his ability to maintain his connectivity over the satellite. Jam resistance, whether it's being blocked by an adversary or whether there's just a lot of congestion in the spectrum, he has the ability to move quickly between satellites so that he can stay on the network. The last thing I would say is just the new modulation schemes in the modulation and demodulation technologies are creating much higher throughput in terms of bandwidth.